This game is called Get to Zero. We're going to play it decimal style for older students. Each player will begin with 20 points. They're going to be dealt some cards that they will be subtracting from 20 until one of the players gets exactly 0 points. So player 1 and 2 will flip over their 2 cards. Player 2 is subtracting 4 9/10. Player 1 is subtracting 3 3/10. Students can use whatever strategy that is useful to them to subtract decimals. One strategy that they might use is a strategy of compensation. This student might know that if he changes 20 to 19 9/10, it will make subtraction much easier. He's working with a value that is 1/10 less. So to keep the distance the same, he must subtract a number that is 1/10 less than what is shown. This subtraction will yield the same difference as this subtraction because I reduce both of the values by 1/10. If you're not sure about that, check it out on a calculator. So 19 9/10 take away 4 8/10 is 15 1/10 is what I have remaining here. This student saw the really cool strategy and decided to do the same thing. He's going to reduce his 20 by 1/10 and reduce his 3 3/10 by 1/10 to keep the distance the same, making subtraction very easy. And he has 16 7/10 remaining. Player 1 and player 2 are each dealt a new card. They need to decide which place value they want to place it on. Does he want this to read 8 3/10 or 3 8/10? 8 3/10 will take away more faster. Since the goal of the game is to get to 0 first, this would be a wiser decision. So he's going to subtract 8 3/10, leaving him with 8 4/10. This student will do the same thing, subtract out 6 9/10. Now, what strategy do you think he should use here? He could bring this down to 14 9/10, which means he reduced it by 2, which means he has to reduce this one by 2/10. And that will leave him 8 2/10. Each student gets another card. This student can do 8 7/10, but notice they don't have that much left, so that's not a possibility. So they will have to do 7 3/10. This student can choose 6 2/10. They have plenty to do that with, or 2 9/10. This will get rid of more faster. So he's going to choose to subtract 6 2/10, leaving him with just 2. So now this student can say 5 3/10 or 7 5/10, which are both too large. So instead what he's going to opt to do is flip this deck over to make it a 0 and just play in the 10ths place, leaving him with 6/10. This student, 7 2/10, 6 7/10, both of those options are too large, so he's going to choose to do the same thing, make his ones place a 0, so he has 0 7/10, leaving him with 1 3/10. Each student gets a new card. 8/10 is too large, so this student misses a turn. This student can choose to say 4 7/10 or 4/10. Since 4 7/10 is too large, he'll choose just simply 0 4/10, leaving him with 0 9/10. He'll choose to make this 1/10. This student, let's go ahead and move this up, is going to subtract out 2/10, leaving him with 7/10. Player 1 has 3/10 remaining now. with no whole numbers. Player 2 drew a 7, giving him 7/10, which means that the student player 2 won the game because he got to exactly 0. Have fun playing Get to Zero.